Welcome back, everyone, to the smartest year ever, our quest to become the world's greatest conversationalist. My name is Gordy, and today we are talking about earthquakes. Specifically, what does the Richter scale actually measure, and what is the biggest earthquake of all time? Like and subscribe if you haven't, so you can keep up every single day. I do this every single day. First off, the Richter scale measures earthquakes' magnitude based on the amplitude of seismic waves. The word seismic comes from the Greek seismos, meaning earthquake or shaking. Makes sense. Seismic waves are the vibrations that travel through the earth when a fault shifts or breaks. Basically, they're the shock waves from an earthquake. But here's an important fact for interpretation. The Richter scale is not linear, it is logarithmic, which means each step up isn't just a little stronger, it is 10 times the wave amplitude. For instance, a level 6 quake has a shaking that is 10 times bigger than a level 5. And a level 7, that's 100 times the wave amplitude of a level 5. So when you go from a 6 to a 9, that's 10 to the third, or 1,000 times more shaking amplitude. And that's why small sounding differences are a huge deal when it comes to this scale. But shaking isn't the same thing as energy. In terms of total energy released, each full number jump equals roughly 32 times more energy. To give you an idea, quakes in the 4s and the 5s rattle windows, maybe knock things off the shelf. Quakes in the 7s can flatten cities if close enough, and 9s shift coastlines. So check out this little nifty graphic that breaks it down. You know, you can really see here that it really gets bad over 7. I mean, 6 is strong, 7 major, 8's great, 9 great. But I think that means like extreme. And you can see that there are occurrence amounts. I think that's kind of an interesting chart. Yeah, you don't want those. You really don't want those. And to put it into perspective of the earthquakes you might know, in 1994, the Northridge earthquake, it was in California, and it was a 6.7. It was scary, it was destructive, but it was largely localized. The 2011 Tohoku earthquake in Japan, that's the one that triggered that tsunami and that Fukushima nuclear disaster. That was a 9.1. That's huge. The Richter scale was developed in 1935 by Charles Richter and Beno Gutenberg. I'm going to say Benno Gutenberg. Originally, it was designed to compare small to medium earthquakes in Southern California using a specific instrument called the Wood-Anderson seismograph. In fact, it wasn't even meant to measure massive or distant quakes, and that's part of the reason why it eventually got replaced, because today seismologists use the moment magnitude scale, MW, instead, which is better at capturing the energy of large quakes across the globe. But the term Richter scale stuck in the public consciousness, kind of like how we're saying we're going to dial the phone or hang up the phone, even though there's no dial and there's nothing to hang your iPhone on. While magnitude tells you how big the earthquake is, impact depends on more than just that number. Depth matters. Like a 6.0 that hits 300 miles underground might be barely felt, but a 6.0 that strikes 10 miles below a densely populated city, that can be deadly. The kind of rock, building standards, and even time of day all change the outcome. Also, the amount of warning you get depends largely on your distance from the epicenter. Living in Southern California now, having never experienced an earthquake before moving out here, it's a weird feeling. You don't get a lot of heads up. If you're going to get walloped by a major earthquake, your warning time might be, if you're lucky, 30 seconds, a minute, but could be none at all. You're just going to feel it. Fun fact, the largest earthquake ever recorded was the 1960 Valdivia earthquake in Chile. It clocked in at a 9.5, which is the highest magnitude that we've ever seen. It killed an estimated 1,000 to 6,000 people and left over 2 million homeless. The earthquake triggered a massive landslide that dammed a river, widespread flooding, and a series of tsunamis that hit Chile within 15 minutes. It also struck Hawaii, Japan, the Philippines, and even the west coast of the United States. And the reason it was so especially devastating was because Chile sits on the Nazca and South American plate boundary, one of the most seismically active subduction zones on Earth, where an entire oceanic plate is being forced under the continent, storing enormous tectonic pressure. Not tectonic pleasure, tectonic pressure. So I was looking up some of the top earthquake hotspots in the U.S. because I thought that was interesting. Alaska, that has the most powerful quakes in U.S. history. California, San Andreas Fault, we've probably all heard of that one. It's especially dangerous just due to the population centers that are on that fault, like Los Angeles and San Francisco. In the Pacific Northwest, there's the Cascadia subduction zone that can produce 9.0 plus megathrust earthquakes. That's no bueno. Missouri and Illinois, the New Madrid seismic zone, massive quakes occurred in 1811 and to 1812, and that's probably due again. Utah, Idaho, and Wyoming, the Intermountain seismic belt, that's a big one. And also on the East Coast, Charleston, South Carolina is the most active region on that coast for seismic activity. So there you have it. The Richter scale might be outdated, but the logic behind it has changed how we measure the Earth's power. It's not just about how big the quake feels, it's about energy, wave behavior, and how exponential math reshapes the ground beneath our feet. Thanks to all my sources, which can be found in the YouTube description. Please give me a rate, follow, like, subscribe, share this with someone who likes this sort of thing. I'd really appreciate that. Share this with someone on a subduction zone, and go check out the 1-minute version. The 1-minute version is on social media, all the social media platforms at Smartest Year Ever. And in the meantime, stay curious and stay clever on our quest to become the world's greatest conversationalist. I will see you tomorrow in the Smartest Year Ever. And I'm hoping you're not finding this video because there was a giant earthquake. For real.